Hello everyone, welcome back. During this tutorial, we will talk about Android Jetpack WorkManager. With very easy to understand, simple code examples, I will teach you how to implement one-time work request and periodic work request. I will teach you about how to get status updates and how to set input and output data from a background task. You will learn about setting different constraints for a task such as battery charging level and availability of a network connection. We will also cover chaining of workers. As usual, I have provided download links to final code project and links to written notes of this tutorial in the description of this video. So, let's start. WorkManager is the new Android background task management system came with Jetpack. We use WorkManager to run deferrable, that means capable of being postponed, background works. Most importantly, WorkManager provides the guarantee that the system will run the postponed task even if the app closed. WorkManager will take care of the logic to start our work under a variety of situations, even if the user navigates away from the app. Before WorkManager, we used Firebase, Job Dispatcher, Job Scheduler, and Alarm Manager with broadcast receivers to schedule tasks. Scheduling tasks was complex and time-consuming. We had to write codes to deal with a lot of constraints and requirements. But now we have WorkManager. All we need to do is pass the task to the WorkManager. It will decide which scheduler to use considering the requirements, and it will take care of constraints. If the device API level is less than 23, WorkManager will use a combination of broadcast receiver and alarm manager. If the device API level is 23 or higher, WorkManager will choose job scheduler. If our task uses Firebase, WorkManager will choose Firebase Job Dispatcher. WorkManager offers a lot of advanced features. It supports chained tasks. WorkManager provides status updates as live data. It allows us to set constraints on when the task runs. WorkManager uses less amount of system resources like battery power. It handles compatibility with different Android versions. It supports asynchronous tasks. It also supports periodic tasks. WorkManager is not for tasks that needs to be run in a background thread but don't need to survive process death. For normal background tasks, we don't need WorkManager. We can easily use coroutines or RxJava for them. These are the two types of work requests we use when schedule tasks with WorkManager: periodic work request and one-time work request. Let's say we have an app created for a sales team. Each salesman needs to see current stock count of the products. Therefore, our app should have regular updates from the main server. So, in this case, repeatedly updating stock details is a task, and with WorkManager, we can set up this task to repeatedly run, let's say, at around 30 minutes time period. That type of work requests are called periodic work request. Now, let's say we have an app created for a survey team. Each member will insert new survey records, including images, and hit on save button to upload them to the main web server. So, in this case, uploading survey details is a task. With the support of WorkManager, we can schedule this task to run at an approximate time considering the availability of the internet and the battery charge level of the device. This type of work request are called one-time work request. These are the 4 basic steps of scheduling a task using WorkManager. Create a subclass of the worker class, create a work request, enqueue the request, and finally get the status updates. During the next lesson, let's schedule our first task using WorkManager. I am going to start by creating a new Android Studio project. Select Empty Activity. Let's name this as WorkManager Demo 1. I have selected the language as Kotlin, API level as 26. Let's click on the Finish button. Now, first of all, we need to add required dependencies to use WorkManager to the app level build.gradle file. We can find WorkManager dependencies from this page. Let's sync the Gradle. Now, let's create a worker class. This class will be executed by the WorkManager instance when the conditions meet. Let's name this as Upload Worker. This class should extend the worker class. This is the parent class, androidx.work.worker. We need to always implement doWork function of the worker class. Let's generate it. And this worker class has two constructor parameters, an instance of context and an instance of worker parameters. Alt plus Enter to import the class. Then we need to pass them to the constructor of the parent class. Now, inside this doWork function, we are supposed to write the code to execute the deferrable background task. But in this lesson, our goal is to understand WorkManager basics properly. So, for now, let's just add a for loop with the log to simulate the task. Let's add a log. This doWork function should always return a result. Return result.success. So, this is for success. If any error happen, this function should return failure result. I am going to add a try catch block for that. Now, let's switch to main activity. Here, I am creating a new function. Private fun set one-time work request. Inside this function, I am going to write codes to tell WorkManager to perform the task. Our task is a one-time work request. We will learn about periodic work request later. So, we need to have a one-time work request instance. Well, one-time work request equals one-time work request.builder. Here, we need to add the worker class we just created. Then, build. Next, we will use a WorkManager instance to perform this task. WorkManager.getInstance. We need to pass the context here. Then enqueue one-time work request. Let's rename this as upload request. That's much better. Name is not a problem. You can add any name you like. Now, I'm going to add a button and write codes to trigger this task inside the click listener of it. Go to activity_main.xml file, switch to design mode, drag a button, set constraints, let's change the text on the button. Change the text size and text style also. We will use this text view later, so let's modify it too. I'm removing the text on it. Change the text size to 30 and text style to bold. Okay, now let's go back to main activity. Then in this onCreate function, I'm implementing the click listener of the button. Let's go to the set one time work request function from here. Okay, let's run the app and see how this works. Let's open the logcat and see the results. Good, app is working as we intended. During the next lesson, let's write codes to display the status updates received from the worker class. For each work request, WorkManager allows us to get a live data of type workinfo. Workinfo object contains information about the work. By observing it, we can determine the current status and other information about the work. Let me show you how to do it. To observe live data, we need the WorkManager instance. We have already used the WorkManager here. So, instead of invoking getInstance twice, let's define this as a separate variable. Well, WorkManager equals WorkManager.getInstance. Pass the application context. Now, replace this part with our new instance. Right? Then, I am going to write codes to observe the workinfo. WorkManager.getWorkinfo by ID live data. Here, we need to provide the ID of the work request. Upload request.id. Then observe. Owner is this activity. Observer. Here, you can see we have a workinfo object as it. Then, we will display the current state of the work on the text view. Textview.text equals it. You can see various information we can get from a workinfo object. State.name. Now, let's run the app and see how this works. We can see the state as succeeded. Actually, a work has 4 states: blocked, enqueued, running, and succeeded. Blocked state occurs only if the work is blocked in a chain of works. Work enters to enqueued state as soon as the work is next in the chain of work and eligible to run. If there is a constraint to be met, work will have to stay in the enqueued state. When a work is actively executing, it is called running state. After a work successfully completed, work enters to succeeded state. Actually, we will be able to see the running state if we increase the value of this for loop. Let's make it 600,000. Run the app again to see how this works. You can see the running state now. And finally, work entered to succeed state. So this is how we get state updates from a work. During the next lesson, we will talk about constraints. When we are using WorkManager, most of the time, we need to write codes to run tasks under different specific conditions. WorkManager uses constraints provided by us to decide when the work should run. As an example, let's say our app has a large video file to upload to the backend server. It is a battery-consuming task. In that case, we might need to specify that the task should run only when the device is connected to the charger. Let me show you how this works with the code example. Let's create a WorkManager constraints instance using constraints.builder. Well, constraints equals constraints.builder. There are a lot of constraints we can set. For now, let's set requires charging as true. Next, build. Now we need to add this to the one-time work request instance. Before run the app, let's check the charger settings of our emulator. At the moment, charger connection is none and battery status is not charging. So, if we run the app now, if our WorkManager constraints work properly, WorkManager should not execute the task. Let's see how this works. Now I am going to click on the start button. We are not seeing any log results, so WorkManager hasn't started the background task, and our work is in the enqueue state. Now I am going to change the battery status from not charging to charging. Set the charge connection as AC charger and battery status as charging. Did you see? As soon as we changed the battery status from not charging to charging, our task changed from enqueued state to running state. Now, what will happen if the user exists from the app before plugging the device to a charger? Actually, the WorkManager library has a local database that tracks all of the information and status of the work. That database is what enabled WorkManager to guarantee the execution of the work even if the user exists from the app or user's device restarts and work gets interrupted. Now, let's add another constraint. This time, we are going to check the internet connection. Before add constraints for the internet connection, we need to go to the Android manifest.xml file and add permissions to use internet. Let's also add a permission to access network state. Then here in the main activity, all we need to do is this: set required network type, network type.connected. Now to test this, I am going to change the emulator to airplane mode. Then network type will be disconnected. Let's run the app and see how this works. As we expected, our job is in the enqueued state. Now, let's remove the airplane mode. As we intended, work moved to running state and then to succeeded state. So, that's how we add constraints to works. I'm going to end this lesson now. During the next lesson, let's talk about how to send and how to receive values from a task. During this lesson, I will teach you how to set input and output data with WorkManager. When working with WorkManager, we might need to pass some arguments to a task. To do that, we need to create a data object and set that data object to the request object. let's create a new data object. Well, data object type is data. Let's import the class. Equals data.builder. For now, let's add just an int value as an argument for the count value of the for loop. Here, we need to specify a constant value as key. For that, let's create a Kotlin companion object. Then I am defining a constant for the count value. Now we can use it below. Let's add 125 for the key count. Then build. Now we need to add this data object to the request. Now let's go to the worker class. Data object. WorkManager class has a getter function called input data. We are going to use it here. Well, count input data.getInt. Here we need to provide the constant key value we defined in the main activity. I am inserting 0 as the default count value. Now let's modify the for loop. Let's run this app and see how it works. Good. Our worker class receiving input data as we expected. Sometimes we need to get some return data from our worker class. For this example, I am going to write codes to send the task finished time to the main activity. Actually, we are doing the same steps to other side to get the input data from the main activity to worker class. We defined a constant in the main activity. Now, to send output data from the worker class to the main activity, we need to define a constant in the worker class. Then let's write codes to get the finished time. I am using simple data format class here. Let's add the pattern to get the time with the date. Then get the current date. Import the class. Now let's create a data object to send output data. Well, output data data.builder. Since we are sending the time as a string value, this time we should use putString. Key and the value. Then build. Now we need to pass this as an argument to the result. Now let's go back to main activity and write codes to receive the output message. Here, inside this observer block, we can write codes to receive the returned string value. we cannot get a return value if the work is not finished. So let's do a validation for that first. Then get the data object. Next, we can get the string message using the key. Finally, we can display the toast message. Now, it's good time to run the app and see how receiving output data from the worker class works. Good, as we intended, finish time displayed as the toast message. So, that is how we handle input and output data with WorkManager. During the next lesson, we are going to talk about chaining. With WorkManager, we can sequentially and parallelly chain different tasks. As an example, let's say we need to upload some images to a server. We need to filter them first, compress them, and then upload them to the server. We already have a upload worker class. Let me very quickly create 2 more worker classes for the demonstration. I'm naming this as filtering worker. We can copy these codes from upload worker class. Change the name. We don't need this companion object. We don't need input data. Let's just set this to 300. And I am changing this as filtering. Let's also remove these codes. Now I am creating another class. Naming this as compressing worker. Let's copy paste from this class. Change the name. Change this to compressing. Now let's go back to main activity. Here let's write one-time work request for our new worker classes. Okay, this is how we chain workers. Begin with filtering request, then compressing request, then uploading request. Finally, enqueue. This has to be empty now. So, this is sequential chaining. You can chain any number of workers using this then function. Now, let's run the app and see how this works. Let's see These are from filtering worker. Then compressing worker. So chaining is working as we intended. Now to demonstrate parallel chaining, let's assume we need to download some images from another server while filtering the images in the phone. For that, I am creating a new worker class. I am naming this as downloading worker. Copy paste and modify the code. Let's make this 3000. And let's also change the number from filtering worker to 3000. Otherwise, we might not be able to see any significant difference. Let's create a work request instance for our new worker. When we are chaining parallel workers, first we need to add them to a mutable list. Let's create a mutable list instance of one-time work request. Then add the parallel workers. Now we should pass that list to this begin with function. Now let's run the app and see how these new codes work. You can see these logs from download request and filtering request have mixed. That indicates a parallel execution. After that, you can see a sequential execution for compressing and uploading workers as we intended. So that's how we do chaining with WorkManager. During the next lesson, let's talk about periodic works. If we have a background work which is repeated periodically, we should use periodic work request. For now, Android Jetpack periodic work request has a minimum period length of 15 minutes. I am creating a new function, private fun set periodic work request. Then let's call to it from the one-click listener of the button. Now I am going to create a periodic work request instance. Well, periodic work request equals periodic work request dot builder. Let's add downloading worker class we created during the previous lesson. We have two extra parameters in this builder, repeat interval and the time minute of the repeat interval. Let's set the repeat interval as 16 minutes. For now, Android Jetpack periodic work request has a minimum period length of 15 minutes. So we have to always specify 15 minutes or more. And here the time minute should be time minute dot minutes. Then build. Now let's get a WorkManager instance and enqueue this work request. WorkManager.getInstance, application context, then enqueue, pass the work request. Now if we run this, downloading worker will run in every 16 minutes time interval. We can copy this current time code part from this upload worker class and paste it here in the download worker class. We can use it to test the time interval. Okay, now let's run the app and see how this works. So this is the completed time. Now let's wait some time and see if WorkManager repeating this task as we intended. Yes, we got the second set of results after 16 minutes. So this is how we use WorkManager periodic work request for repeating works.